When working with Kubernetes resources, most of the time we define them as YAML. But here's the thing, YAML is a data format, yet more often than not, we do not use it as such. We use it as if it's free text. So let's see whether we can change that, whether we can focus on data when working with YAML instead of free text templates like Helm, for example. The official explanation or description of YAML says that it is a digestible data serialization language. Yet, we tend to use it as if it's a free text format. We tend to apply text-based formatting on top of YAML using tools like Helm. Why do we do that? Wouldn't it make much more sense to manipulate YAML as if it's supposed to be manipulated? Shouldn't we apply data structures on a data serialization language? So the language is about data serialization, and therefore it would make perfect sense to manipulate it through data structures. Now, I already explored Kustomize, a commonly used tool to manage Kubernetes resources. If you haven't seen it, there's the link, there's the banner, the link is in the description. I compared it with Helm. There's a video for that as well. And I have a video about JSONnet with Tanka, Grafana Tanka. So you might want to check those three because they're commonly used ways to manage Kubernetes resources or to define Kubernetes resources. Today, we are doing something completely different. We are going to explore the fourth contestant to be your go-to tool to manage Kubernetes resources, and that one is called YTT or Carvel ytt. So, what is it? Well, YTT allows us to template and patch as needed to easily make configuration reusable and extensible. At least that's the official description of it. We are yet to see whether that's really the case and how it works. Yeah, but let's skip that. Let's jump straight into a demo, see how it works, and then talk about it. Let's dive straight into Carvel and execute a command that says, YTT, I want to apply something in a file that is, or files to be more precise, located, in my case, in the directory YTT and then _YTT_lib and resources. Let me just execute that command, and later I will show you what's in that directory, what did we do. So I got typical Kubernetes YAML. I have a deployment with a bunch of stuff inside, and I have a service. So the output of that command is what you would expect to be a couple of Kubernetes resources that I can just pass through kubectl or any other tool and apply to my cluster. So the output is what's expected, but let's see how did I get to have that output, and I will do that by listing all the files in that directory. I'm starting easy on you, right? I will complicate it later. For now, let's see a simple example. Let's see how did I get that output. And in the resources directory, I have config YAML, labels.lib.yaml, and schema.yaml. What should we start with? Let's say schema. Let me output schema itself, and we can see a special instruction at the very top that says, hey, this document is value schema data type, and it contains something that are obviously values. I have a name of an application, port, version, and I have ingress, which might have host value, but that ingress can be nullable, meaning that it is not mandatory, it is optional. So think of this as equivalent to values YAML in Helm. Those are the default values, or what YTT calls schema, that can be overwritten later on. Now, apart from having values themselves, we can have libraries or functions. And in my case, the functions are in labels.lib YAML. So let's output that one. Again, just as before, there is a special instruction at the top that says, hey, this, actually, it's not an instruction. It just says this is the file labels.lib YAML. Doesn't matter. What does matter is that I'm defining a function called labels that accepts name and version as input arguments, and then we'll output two labels, app Kubernetes IO version and name, and both of them will have values that come from the arguments of the function. So in other words, I can have functions that return some values, YAML values, because remember, it's a data format, not a template, right? Not free text. Anyways, a function that returns data. And finally, there is config YAML in that directory, so let's output that one as well. And this is similar to what you would normally have in the templates directory of Helm chart. And it contains the instruction that says, hey, first of all, you need to load the data and the libraries and everything that I showed you so far. And we are going to define yet another function directly here. So functions can be defined in multiple places. And that function is going to be similar like labels function that says, hey, there should be a function called image. It accepts two arguments, and I'm going to return the image that should be used in a deployment that is based on the name of the image and the version. And then we have deployment, Kubernetes deployment of sorts. So it's a typical YAML that has values treated as data. So we can see that the value of metadata name is whatever is supplied as the value's name, and labels is the value of the labels function, and there are other labels here in the definition. So far, this is very similar to Helm, right? We have some YAML, and then we have some values that are injected in that YAML, except that Helm is pure free text format. You can replace anything, while in case of YTT, we are dealing with templating values only, which could be directly values or outputs of functions. And we can have conditionals, like in this case, it says, hey, if data values ingress is defined, then whatever is below it should be output as well. You remember that when I output the values, the directory with the YTT, we did not have ingress because I did not specify ingress. So here we can use some kind of conditionals. We can use quite a few other things, not only conditionals, but I will get to that later. And within that ingress, optional ingress, we have another set of values that can be values themselves or functions. Pretty Helm-like, right? What matters here is that that conditional ends with the end instruction, and then we have a service with another substitution of values. So if you're used to Helm, this is very similar, and you might say, hey, why would I use this in the first place? And that's a very valid question, but you might want to postpone asking that question until later. Now, when I applied the resources directory, or to be more precise, passed it through YTT, I used only part of what I have, because resources, while they can be output directly, we might want to control and treat those resources maybe as libraries, right? Or, as the name says, resources. Now let's see what happens if I go back one or two directories back and execute YTT, and then the file, whatever, all the files and subdirectories and directories in the YTT directory. Now I got much more here. Previously, when I passed resources directory through YTT, I got a deployment and a service of a single application, but this time I have deployment of the app called Silly Demo, fully output passed through YTT combined with data and all those things. I got service of the Silly Demo. I got deployment of the second application called DevOps Toolkit series, ingress for that second application, not for the first one, and the service. So two applications, both of them with deployments and services, and one of them with ingress, right? So I use the resources that I showed at the very beginning as a sort of template, as a reusable pieces, building blocks that I could reuse to define two of my applications. Now that could be a potential lifesaver or time saver, right? Or saving the number of lines. So let's see how I did that. let me output the contents of the YTT directory. There is YTT lib subdirectory. I already showed that one. That's the one that contains resources. What matters here is that I'm adding two more files to the mix. One is config YAML in the root and values YAML. Those two files will define how I want to customize the resources to construct two different applications. So let's take a look at config YAML first. Here we can see that it loads the data and the libraries and the templates. It loads stuff that's in a similar way as you would load libraries in a programming language. We can see that I'm importing or loading or retrieving the resources that previously I used directly. And then I'm saying, hey, I want to generate two resources or two sets of resources. One is called silly demo that will use the resources library and combine it with data defined as data value silly demo. And the same thing with DOT that is using the resources library and then combining that library with the values defined as dot. And then once I have those two variables, I'm saying, hey, I want you to replace the values of those resources with the values of the data that I'm passing, evaluate it, and that evaluation is going to already spit out the output. It created all those manifests. So this is definitely more cryptic, or at least on a first look, than let's say Helm, but it allows things that Helm really does not permit, at least not that easily, right? This is treating templates as data combined with being somehow a programming language of sorts. It could be a strange combination, but we're going to talk about it later. Now, the values YAML file contains the values that I use to combine with the resources, and I have silly demo, as you can already guess, that has only the name and the version, and DOT that has the name and the port and the version, and it says, hey, for this one I want to use ingress, and if ingress variable is defined, then ingress resource will be output as well. Now I could also have different variations of those applications by applying or combining resources with different values. I could have one set of specific values for the development environment, another one for staging. So let's try to do that. Let's output my applications for the development environment and then for staging. So the first command would be YTT. I want to use the files in the YTT directory, but I want to combine them with a special separate values file, which in this case is called values.dev. Actually not dot, values-dev.yaml. And here we can see some differences. For example, the host is not DevOps Toolkit series.com, but DevOps Toolkit series.127.001 NIPIO, which is something that would work on my local Kubernetes cluster where I'm supposed to be deploying this application while developing it. And I can generate another set of files for, let's say, staging that is going to have some other variations. Like in this case, the host is going to be staging.devopstoolkitseries.com because staging is supposed to be permanent real environment with real DNSs, but still shouldn't have the same domain, same host as production. So let me output values-dev.yaml, and we can see that here for the silly demo application running in the development environment, the version of the image is going to be latest, and the same version latest will be used for DOT, but ingress is going to be special. It's going to be based on nip.io. And I can do the same. Let me output staging, see what's the difference between dev and staging. And we can see that in staging, I want specific versions of my applications and specific host, right? So I can have different set of values treated as data that are stacked on top of each other, one overwriting the other until we get to the top of the stack. In this case, those values.dev and -dev and values staging YAML files. Now, if I would like to apply those resources in my Kubernetes cluster, I can do something as easy as YTT file is whichever directory, and I want special values file that is going to be value staging, and that is going to output manifest to stdout, and then I can pipe it to kubectl namespaces production apply file name dash. Or I couldn't mean that created my resources in my cluster, but I could have output it to file system and then store that in Git, or I could do whatever I need to do with those outputs, either as files or stdout piped to some command. In other words, YTT is not really concerned on how we manage resources in Kubernetes. It does not really care about kube API or any of those things. It just outputs manifests that were created as a combination of templates and data provided as values. And data can be functions as well. And there are quite a few other instructions, but we are going to talk about that in a moment. Let's finish the demo here and jump into a bit deeper explanation of what YTT is and pros and cons, and make a decision whether we should use it or not. So, what is YTT? Well, it is a language rather than a templating machine of sorts. It is based on modified version of Starlark. Now, Starlark is originally Python thingy, but in this case, it is a Go implementation of Starlark. So it is a Starlark-like language written in Go, and it supports different types, like it could be none, or boolean, or integer, or float, or string, or list, or tuple, or dictionary, struct, YAML, fragment, annotation, and so on and so forth. So it is a language that supports different types, which are treated as data, and we have conditionals like if-else statements, for loops, functions, and so on and so forth. So it is a language of sorts. And as such, it is conceptually very similar to JSONnet. By the way, if you haven't seen the video about JSONnet with Grafana Tanka, another reminder, go to the description, you will see the video. I think it's absolutely awesome. So it's conceptually similar to JSONnet, but not really. It's not as much of a language as JSONnet is. So it is more of a templating machine than a language. So from that perspective, it is closer to Helm than JSONnet. Actually, that's not true either. It operates on data structures instead of templates. So it's not really Helm, but it feels like Helm. It's a strange beast. I really cannot wrap my head around what YTT is trying to be. Is it a language? Is it a templating mechanism? Is it closer to JSONnet or closer to Helm? It's a strange beast. Because after all, JSONnet is a custom language, while YTT is templated YAML and Python-like language for templating. So I would say it's closer to Helm, probably. Now, what makes YTT potentially better, or not necessarily better, but easier than JSONnet is that we do not need to transition to JSONnet for defining stuff. We can continue using Helm. So transition to YTT from, let's say, Helm might be easier than transition to JSONnet. Now, how much that helps or not is unknown. But let's jump into pros and cons. Let's go with pros. It is potentially more powerful than Helm or Customize. If you have complex setup, if the outputs, the manifests that you need to manage are complex, then YTT could be very, very helpful. It is going to solve some of the pain points of Helm, and Customize was never supposed to be meant to be used for complex setups. So if what you do is complex, and wait for a second, not complex in general, but complex on client side, right? Then YTT is a potentially good solution. So it is very, very powerful. What we can do with it is really, really awesome. Now, whether you need that complexity or not, that's a different subject, right? Another big advantage is that it focuses on data rather than free text templates, right? So it is closer to what and how YAML is supposed to be used, because it is a data serialization language. Now, about negative things, cons. To begin with, docs are amazingly detailed. So you might be wondering, why am I putting docs in negative section in cons, because they're more academic than practical, right? There is a lot of detail in the docs, and that's all great, but if you read it from the start to the end, your head is probably going to explode. It's like reading doctorate dissertations rather than a useful guide, with quick start and taking you step by step until you get somewhere. Now, another complaint that I might have about YTT is that it could be taking declarative formats to the wrong direction. If you need such complexities with libraries and conditionals and what's not, if you do need it, which I don't think we do, but if you do, then maybe a programming language like Go or Pulumi or Q could be a better choice, right? It could be taking YAML to a whole new level of complexity. Another issue is that it is not supported by other tools outside of Carvel ecosystem. So if you stay within Carvel toolset, which is actually great, more or less, then you're fine. But if you want to combine it with Argo CD or whichever other tools you're using, you might have difficulties over there because it almost like lives in isolation, YTT, from the rest of CNCF landscape. It's meant to be part of Carvel package rather than interacting directly with the rest of the ecosystem. So it's not supported by other tools, at least not as widely as it should, and it is not really supported by other vendors either. It is very much in the Carvel ecosystem, which I mentioned, and the VMware box, right? Which there is nothing wrong with it. It really depends on how much you're committed to Carvel and how much you're committed to VMware. If you are, then great, you get the whole ecosystem and YTT is part of it. But if you do not adopt that ecosystem, then it has questionable value, even though it's great. You just need to figure it out. You need to learn how it works. But after that steep learning curve, it's actually pretty good if you like VMware and Carvel and Tanzu and the whole story. Now, if I talk about it in isolation, there might not be a good reason to switch from Helm or Customize to YTT alone unless what you do is complex. And if it's complex on the client side, then maybe you should think about creating custom resource definitions and simplify actually move the complexity to the server side inside of your clusters, but that would be a completely different subject. So, all in all, YTT is great if what you're defining is complex, you're not into creating custom resource definitions and moving complexity to the server side, and ops are managing your resources, because let's face it, devs are not going to adopt Carvel. It's just even more complex looking with steeper learning curve than alternatives. That steep learning curve might be justified for ops, but not necessarily for devs. So it is not Helm, yet it feels like Helm, complex version of Helm that accomplishes more complex results. Now, the main question, the most important question is whether you should use YTT instead of Helm, and instead of Customize, and instead of JSONet, and instead of KPT, or whichever other tool or language you're using to manage Kubernetes manifests.